Welcome back to a new exercise. In this case, we're going to solve a problem that is quite similar to the previous one, but it has a little twist. In this case, the two trains are moving in the same direction, and we're going to end up in the same city at the same time. So let's have a look. A train leaves city A for city B, 400 kilometers away, at 150 kilometers per hour. At the same time, a second train leaves a town in the midpoint between A and B in the same direction. Find the speed of the second train so that the two trains arrive simultaneously at city B. So here we have a difference with respect to the previous problems. Here we are not being asked about the time that it takes for something to happen to the encounter or how far it happened. In this case, the two trains arrive at the same time to the same city, and we don't know the speed of the second train. So let's first focus on the things that we know. First of all, we know the distance between the two cities. We know the speed of the first train, and we also know that the two trains will arrive simultaneously at city B. So that's what we know from the text of the problem. So the next step is, by now you should get in the idea of my personal recipe. Always look for the quantities that are given in the problem. Then drawing. You go for the little cartoon, and for the little cartoon, the first thing we do is we select coordinates. We choose our coordinates. So we draw a line, or in this case it's an arrow, that will represent the x-axis. So as usual, I draw it as an arrow because the x-axis has a direction, goes from left to right. We select the 0 somewhere, we can put it here. This is x equals 0, and we put city A here. So we choose the coordinate so that x equals 0 is at city A, and city B is somewhere. It's on the line here, right there. And we know the distance between these two cities, so let's call this big D. This is 400 kilometers. We know that the first train is traveling at some velocity. We're given that velocity. Let's call this V1, is 150 kilometers per hour. So the second train is starting at the midpoint, so right halfway between the two cities. So if the distance from A to B is D, that means that the location of this town is at D divided by 2. So if D is 400 kilometers, that means that the town right in the middle is at 200 kilometers from A. And this second train will start from here, so it's moving in the same direction with some velocity v2, which is the unknown. We are being asked to find the speed of the second train. So let's do that. We have the cartoon, that means we can start writing equations. We have two trains, that means we're going to have two equations. Just as before, we start with train 1, for which we know its location can be written as x1 equal to x1 initial plus v1 times t1. The initial position is 0 because the coordinates were chosen in such a way that that quantity was 0, so it's not a surprise. And we simply get v1 times t1. So this is the position of the first train. For the second train, we have exactly the same equation, but now with subscript 2. So x2 is x2 0, that means the initial position of train number 2, times v2 times t2. The second train starts right in the midpoint, so we know that this quantity is going to be d divided by 2, and the rest remains the same. So now we have the equation for our second train. So up to this point, the two trains are completely unrelated. There is no connection between them. So here's when we define that the two trains will meet at city B. This is what is given in the problem. It says that the two trains arrive simultaneously at city B. So we can call this the meeting point, which is city B. So at the meeting point, we can set the particular condition. And this is what will relate the two equations. So at the meeting point, we know that x1, the position of the first train, must be equal to the position of the second train, and that must be equal to d, which is where city B is. The other condition is that given that the two trains started at the same time, the time that they will travel is going to be the same. So t1 is going to be equal to t2, and we can simply call this t. So we can now impose this condition in the equation for each train. So for the first train, we have that x1 is now big D, and this is equal to v1 times t1, which is now simply called t. For the second train, we have x2 is also now big D, is big D divided by 2 plus v2 times t2, which is now just t. So now we have two equations and two unknowns. We don't know the time, which appears here, and we don't know v2, which is the quantity we're trying to find. So this can be simplified a little bit if we solve for t in the first equation, because we know big D and we know v1. So from this equation, I could simply write that t is given by d divided by v1. And now I can simply replace this quantity here in this equation. Okay, so I will replace whatever I see at t, I will replace it by d divided by v1. I will pass this d divided by 2 to the other side, so I get d minus d divided by 2 is the same as v2 times t, which, as we just said, will be replaced by d divided by v1. The left-hand side can be simplified. D minus d divided by 2 is the same as d divided by 2. So this becomes d divided by 2, v2 times d divided by v1. The quantity we're looking for is v2. So we need to pass this v1 to the other side and also the d to the other side. That means we have to multiply by v1 and divide by d. So this is d divided by 2 times v1 divided by d. It's going to be the same as v2. The d cancels, so it's completely irrelevant, and we find that v2 is just v1 divided by 2. In other words, the second train must move at exactly 1/2 of the speed of the first train. Since the first train its velocity was known, is 150 kilometers per hour. We simply divide this by 2 and we get 75 kilometers per hour. That is the velocity of the second train, so that they can meet at city B. They will arrive at city B simultaneously. So in the next problem, we're going to introduce an extra degree of complexity. So far, the time for the two trains has always been the same. In other words, the two trains start at the same time and finish at the same time. We're going to see situations in which the two trains start their motion at different times. So don't miss the next exercise.